Hello, my name is Joe Kim, and I've taken upon me to disprove a common physics misconception stating that an object's natural state is rest. So, to help me out, I called up Newton. He gave me a few sage words. So, Newton's first law: an object's natural state is not rest. Or, an object will remain at rest or in constant motion unless exerted upon by an external force. And to help you cope with this idea, I have devised some candid illustrations for your convenience and pleasure. So, an object not in motion. Let's say, in this case, a fat man, a rather big boned man, sat down and was incapable of standing back up. So, therefore, his big boned stature results in him having a mass of 1,020.31 kilograms. And this results in him exerting the ground with a force of 9,999 newtons, with the ground exerting the same force of 9,999 newtons on him, preventing him from going through the ground. So therefore, this force body diagram, or in this case one could argue a fat body diagram, would look like this. There's no x-planar forces being involved since there's no force being applied, nor is there any force of friction. But I do imagine that static friction would be ridiculously high for a man of his size. So, anyways, his f of n would be equivalent to his f of g, because stated before, he's neither falling through the ground, neither flying upwards. Let's just say, in this case, you're in constant motion. So you're ice skating on a rink, and you're quite good at it. So you lift up one leg and you're gliding across at a constant velocity, neither accelerating nor accelerating in a negative direction. So your FBD, your force body diagram, will look like this: FBD-A. As you can see, there's no x-planar forces being involved here. Simply put, because you're neither applying a force, neither is any force of friction being applied on you. Because in this case, ice is theoretically frictionless. So you'd be maintaining this constant velocity for, I imagine, quite a while, possibly to the end of times. Well, let's say there is a surface that has some friction to it, and you're moving a box on it, you're pulling a box, you work for a moving company. So then your FBD will look like FBD2. As you can see, your force applied on the box is equivalent to the force of friction, resulting in moving the box at a constant motion, neither accelerating or accelerating in the opposite direction. As both forces cancel out, your net force is 0, which would mean either 1, you're not moving, or 2, you're moving at a constant velocity. But in this case, constant motion. So f of n, f of g, quite similar to the fat guy. They're both equivalent, they cancel each other out, because the box in you is not falling through the ground, neither is the box in you flying upwards. Same thing here too. So now that the technical stuff is done and done, I think it's time to move on to the demonstration. So buckle up, Buttercup. We're moving on to demonstrations. Alright, I got a really high quality demonstration in mind. All you need to do is raid your parents' fridge. A couple of ice cubes. Close your fridge door. Moving is so difficult. Okay. You wanna grab? Just wanna grab a nice cube. Just like there. Did you see that? Constant velocity. When it's constantly all the way from here, left a wet trail of water. From here, constantly to where it hit that thing, that bar, which exerted an external force on the ice cube, causing it to stop. And let me show you the other way, where it's at rest. This is the proposed state of the natural state. But then when I exert an external force, it moves, because of an external force. So, I basically proved to you the entirety of Newton's first law with an ice cube.
Thank you for watching.